Hello, everyone. Already Chris introduced me, so I think I will not spend that much time introducing myself. I'm Mateusz Stefańczyk. As Chris mentioned, I'm Google developer expert. On daily basis, I also work as an Angular team leader in House of Angular. I am pretty active core member of Angular Love, if we can call it like that. Used to participate, create a lot of events, content, attending various conferences, and like trying to merge a few communities each other by attending by myself other communities events, because I believe like it's great to create, contribute as a Angular communities, and that's something we actively do as a Angular Love. Today I will try to talk about the signals in modern Angular, how they simplify state management, how they can improve our application. So let's go ahead. So why we talk about the state management problem? So first of all, like it's not only about the state management libraries, but I believe like holding the variable, keeping the value of variable, displaying the value of variable, it's already kind of the state for your components, right? So we have been always doing it over the years, like whether it's the simple variable or whether that were observables, all of this data has been keeping our state actually. So we used to have the behavior subjects everywhere or some other kind of the observable APIs, which lead to some memory leaks, verbose code. We had to trigger pretty often, like manually change detection. If we depends on the wrap variables, we always had to trigger it manually. Of course, in case of the on-push change detection, if we have been assigning the value in kind of the asynchronous context with RxJS, we also had to like trigger the change detection manually. So it could cause some bugs, performance issues, and this kind of the stuff. I believe like every Angular developer is aware of that. We had the complex state management libraries, even though they have been simplifying over the years. The first iteration, the beginning of the state management libraries was tough for everyone, I believe. And the RxJS confusion, when to use it, how to manage subscriptions, and so on. So today we'll discuss what are the signals, like core concepts, we'll explain them. We'll take a look at the most common primitives in scope of the signals API. State management simplified, so how it simplified the most simple state management cases, how we can compare RxJS with signals, what are the compute values, effects, and we'll take a look at the signal store, which I believe is kind of the next iteration in the family of state management libraries, and at the end we will have the Q&A. So starting with what are the signals? So signals are the reactive primitives for managing state in Angular. Also, like there is a Notion smart variable that automatically notify Angular when they change. They automatically trigger change detection. They synchronize by default. They are predictable. They are composable and efficient. Also, like Angular in the documentation mentioned that signal is a wrapper around the value that can notify interested consumers when its value change, right? So simply signal is wrapping the value. It's have some kind of the consumers, so some other signals or our templates. And whenever it's changed, these consumers being notified. We can think of that like that, I believe. It's the pretty simple definition. And they are type safe. So what are the basics of the signal? So signal we import from the Angular core. The creation of the signal is extremely simple by utilizing the signal method and wrapping the value in scope of this parentheses here. So we call the method with the value, right? So signal is a wrapper around the value. So we are just wrapping this value by calling it in scope of this function. And then we can read this value by calling that that function, right? So we are assigning our signal to some variable and then reading it like calling the function. But we shouldn't misunderstand it with actually calling the function, which over the years was treated like an anti-pattern, which was inefficient and so on. Here we are extremely safe. So this function will not be re-triggered whenever change detection occur or something. It will be re-triggered only whenever the value of the signal change. So that's the single reason to re-trigger that kind of the function, like reread the signal. And the single reason for that one is when the value of this signal change. But I can zoom the screen. Let me see. I probably can, but I am afraid that maybe some content will not be visible later. So let me try it now for the second. Changing the size. And if something will not be visible, I will change it one more time then. So 1 second, guys. Is it better now, Phoenix? You need to, guys, let me know and I will continue. If something will not be well visible, just let me know and I can try to even increase this size. Okay, thanks. So it's simply to read this signal. We should not misunderstand it with reading the function actually, which was kind of the anti-pattern as we already agreed and mentioned. And like updating, setting the value of the signal is also extremely simple. We can call the set method, which directly override the value that was in scope of this signal, or just update the value, which of course will change the value, but for the update purpose, we can reuse the past value. And here at the bottom, we can also see like that it can work with any kind of the type, whether it's primitive like number or some complex objects, array of objects, and so on. Okay, here I believe it's fine as well. Sorry, but I'm afraid that something might not fit the content, but here seems to still be fine. So the idea behind the signals is that there will not only replace like RxJS for state management in our components, but also they will replace the traditional variables, right? Because right now, in case of the signals and on push change detection and some, I believe, feature iteration and improvement in scope of the change detection, the signals are the most safe way to go with managing even the simple properties. Because whenever we will utilize the signals, even to extremely simple, even that like flags or properties across of our component, will always be safe in terms of detecting the changes. We don't have to remember that some changes has to be detected whenever we write to the value. Everything will update automatically because it's the nature of the signals. So with the traditional variables, as we can see in scope of, for example, add item, if that component had the on push and detection, whenever we push to the items or we recalculate some value, we always have to remember about triggering the change detection. It's not the case with the signal-based properties. Here, everything will always happen automatically. We don't have to bother with triggering the change detection at all, despite of some edge cases, of course, which we can create in our application. But then in this case, we have to be aware of them. So there is a big confusion because like a lot of our applications already have the RxJS, had this RxJS for years, and I believe in upcoming years there will be places we also will have RxJS because it will be profitable for us. And the question is, should I replace all my observables with signals, or where the signals fit better than RxJS, and so on? So let's take a look at this one. Here is a little bit maybe problem, but still entire content fit, even though it's not looks like. So observables are asynchronous by default, where the signals are synchronous by default. One of them are push-based, other are pull-based. RxJS have pretty complex operators, which we used to know and work with them. We maybe don't need them for all particular cases we have in our application, but they are still cases where it's extremely tough to cover what the operators have been bringing to us, to our programs, our applications. Where the signals are perfect for some really simple computation, recalculation, and creating the one value from another. Observables are great for stream-based data flows. Signals are great for value-based reactivity. What is the benefit of the signal is that they automatically clean up, they are memory safe, and we don't need any kind of the subscription management. Subscription management in RxJS also was something pretty tough, especially at the very beginning and some kind of the old applications. If application is old enough, and we'll take a look at the source code, we can see like probably multiple patterns to manage the subscription. So it shows it wasn't that simple from the very beginning. But I want to say that for me, that we have to use both of them. But we have to use both of them like being aware when we want to actually use the particular one, right? So RxJS is perfect for event streaming, some complex async operations, time-based operations, some advanced operators when we need to switch map, combine latest, fork join, and so on, and HTTP requests when we need some operators. And I believe even now, I still, in my case, use the old HTTP for performing any kind of the request in the application, even though I have the resource. Signals are perfect for component state, derived values, simple HTTP request via resource, because we have to remember like the resource, which works by default with signals, is great for GET, but we cannot perform any other HTTP operation here, like delete, post, and so on. Put, we only can read. Performance critical updates and some shared state via signal store. So we will take a look at this in the future. Here I probably need to decrease the size, sorry, but it's not looks great. So I make some decision framework when to use switch, and for component state, I believe we should use the signals. For HTTP requests, as I mentioned, RxJS and resource. HTTP with retry logic or any kind of the logic where you really need the operators, I will go with RxJS. Form state, well, right now, probably in upcoming months, we can easily say signal forms, but probably Fanis will say us much more about it, how we can utilize the signal forms. WebSockets, of course, RxJS, computed values, computed, global store, signal store, user clicks, extremely simple, like we can handle, but signals, but I don't know, maybe that's even not the use case and I make a mistake here, but some user clicks with the bus or some event streaming logic when you need to some kind of the stream of user clicks or something like that, I believe the RxJS. So let's take a look at the old way of managing the state with behavior subject. I believe this view is known for everyone who has been working over the years with Angular. We always had to like create a lot of behavior subjects at the top of our service, then expose them as observables. Whenever we wanted to update the value, we had to call the next method. Then, of course, we will have there some rather subscription than await. Await like became a good practice in the recent months, I would say. And working with the promise wasn't always the way in Angular. And of course, we have to remember to unsubscribe, destroy our subscriptions, and so on. That's the pseudocode of the things, how it looks like in the past. If we take a look in the way we can manage that with the signals, it's extremely simplified. We only declare the signals. Of course, we can make them as read-only, expose only those signals as a read-only outside of the service, which is kind of the good practice. For update, we utilize the set or update, and like the managing the data is extremely simple. Here, in terms of fetching the data, there is no big difference, I would say. The biggest difference is in readability, composition, and the fact that we don't have to remember about cleaning the subscriptions. But for people who are new to the Angular, I believe this right side kind of the code is much simpler than this left side. Even when we take a look at these filter products, which have to use like combine latest, already some operators to map this value, in compared to the computed, where we think simply return the products, filter it by some conditions. That's it. So we can see there is much more less code. There is simple management of these values, simple management of this code, and no need to remember about the unsubscribing when destroying. So overall, it simplified this kind of the simple state management for our applications. As I mentioned, also like Signal API provide us with a few other APIs around the signals, let's say, right? So like computed fits into the Signal API, even though like we have the signal function. Computed is also kind of the Signal API. And computed is here to create derived values from the other signals. So as we can see, it's automatically track dependencies, memorize results, and only recalculate when needed. So in our case, we have the initial signal, which contains some kind of the card items, and then we create derived signals utilizing the computed function. And as it mentioned, this computed function will trigger and recalculate whenever the signal is based on change. In our case, it will like recalculate its value only whenever the items are changed. And we can create from the items a few smaller properties, like what is the total price or total items quantity, or what is the average item price, which we also can count from some other computed properties. So this is kind of the destination, the dedicated use case for computed to create derived values from the other signals with full memorization, dependency tracking, and recalculation only when needed. The other function from the Signal API are effects. We call it like the side effects, and they are perfect place for tracking some analytics, logging, performing the DOM updates, or synchronizing our application with the local storage. Very similarly to computed, they recalculate whenever the signal they depends on change. Okay, there is also. I was trying to like manipulate this. Maybe I will leave it as it is, because otherwise it's not fit the content. But I still see that some of you have a problem with reading the code actually. I can try maybe one more time to change this to something like that. So the effects in compared to the computed, the main difference is actually that the effects don't return any kind of the value, right? So they are not dedicated for returning as the value, but they will trigger whenever the signal they depends on actually change. We can have there some cleanup management, which is not needed in majority of the cases, but there might be the need that we would like to perform some cleanup logic, which in our case occurs whenever we utilize, let's say, interval in scope of the effect. There is also something to create bridge between the RxJS and the signals. It's called RxJS interrupt, and it's the set of dedicated functions which are here for us to move between the world of observables and the world of the signals. So as you can see here, we have defined the signal and observable, and then we utilize this function to create like the observable from the search term. Then we listening for the search term changes and trigger the API request. And then finally, the results of these API requests we are mapping to the signal from the observable. So this is the kind of the utility we can utilize to feed the signals for our already existing application, where we have a lot of RxJS code, right? So that might be the good fit for the people who already have a lot of things done in scope of RxJS, but they are thinking about the way of fitting the signals into this existing code base. And there is like another API called linked signal, so smart state reset. It's very similar to the computed, but computed have this kind of the restriction that we cannot set directly the value for the computed, right? So computed value is coming from the computation of other signals. Here with the linked signal, we have the possibility of computation the value from other signals, but also we can set directly value to this signal whenever we need it. And the great example for that purpose is scenario whenever you are creating some select component or drop-down component, and you have the set of the option and track selected index, right? But there is a requirement that whenever the options change, you want to bring the selected index to the initial value. So linked signal is perfect fit for this kind of the challenges when we have the options like it's in our code. We have write the options which are coming from the input. Whenever the options change, which are marked as a source in scope of our linked signal, we want its value to be reset to the -1, right? So actually it's not pointing to any kind of the option. But whenever we select the value, we also want to directly set the value of selected index to be equal the index we chosen from the list. And this is the perfect fit for this kind of the opportunities. In the past, people very often utilized effects for this kind of the things, but it was mentioned in scope of the documentation that the effects are not dedicated to synchronizing two signals between each other, right? And then after some time, they released the linked signal, which is the perfect use case for synchronizing two signals value between each other. I believe everything what's there I already explained, so we will not go through these dots. And finally, we are reaching the managing the state utilizing some kind of the external libraries. In this case, it's the signal store. I believe from the NGRX, in my opinion, it's one of the best state management libraries right now for managing all kinds of the states, because it's extremely lightweight and can be used as a global state, feature state, or even component level state. Of course, for some maybe big global state management, the old way Redux-based pattern state might be better. But I think overall that signal store can fit everywhere. And even right now, people are creating some kind of the extensions to the signal store that it can also work based on the events. So very similar to something we had with the Redux. And there is a mention that because I compare like working with the signal store as something as working with the Lego blocks, and I will explain it why, but mostly because we are putting their stuff one above each other, and based of like stacking a lot of things on each other, we are composing the entire state. Like so very similar for something like building something from Lego, when we put another brick above another, and at the end we have some kind of the building or something we are trying to build. Here is very similar. We are just taking a few blocks, putting them together, and we compose our state. So what are the most basic blocks, like the base plate, building blocks, and also what is extremely powerful is the fact that we can even create our custom blocks. So like creating two buildings completely custom to just build something else from that one, or and so on. So the most like basic block for our signal store for sure is the signal store method, which is responsible for initializing the state. And the second one is with state. And the with state is the function where we define the shape of our state, right? And this state will create for signal for each property, provides automatic reactivity, and it's like the most basic building blocks for any kind of the state or store, actually, right? So the state, because that's the purpose of having the store in the application. The second block are the with computed function. As you can see here also at the left, we are just triggering this function one under another, right? Maybe other way than building something from Lego. So we are putting the another blocks under, not above. That's the difference. But we have a few predefined blocks. So the next kind of the blocks are with computed, which let us to create the computed properties from our store. So it's a function that accepts the store as a parameter and returns new properties, being actually the computed properties derived from this store. And all of these computed properties will recalculate whenever the signals they depends on change. So we can see we use the with computed. It stacks on previous block or below previous blocks. It's question of discussion, maybe how we think about it. Another one is with methods, and they are the place for defining the methods in scope, or actually the actions, effects in scope of our store. Depends what kind of the analogy we choose there. But generally, the methods, the purpose of defining the methods, it's like having the possibility to perform kind of the operations on our state, whether that's fetching the new data and setting that data into the state, removing some kind of the entity, and so on, right? So all kind of the methods we will define in scope with methods block. Here we can also inject any kind of the service that is needed for our store to perform this kind of the operation, whether that's the HTTP service or some service which perform any kind of the logic, asynchronous logic, validation, whatever we really need, we can inject at the level of the with methods and then utilize it in scope of our methods. And again, yeah, important to mention that here as well we have access to the entire store. What's important that this store here will be aware of the properties that have been created in scope of the computed, and it works like that. In another blocks we'll be putting below that. These blocks will be aware what has been put above them. So if we'll create like another with methods, so this another with method block will be aware about the add to do method in scope of our store. And we have also the block for with hooks for managing lifecycle hooks. So it's analogy to the Angular components. And here we have like two of them, OnInit and OnDestroy. OnInit might be great for performing some initial load of the data that we are aware that our store doesn't make sense without this data being loaded. So whenever we use this store, whether that will be component or even the global store, it always should be computed and fulfilled with this particular data. So we put this logic in scope of the OnInit in our store that we make sure that this data will be always fetched. There are also other blocks which can help us to manage our data and our store. And one of them is with entities, which provide us with the entire set of helper functions for managing the entities. It might be familiar for the people who works with the NGRX in the past, because NGRX always has been providing a lot of utility functions for working with entities. And we simply initialize this entity collection by calling with entity, providing the model of our entity. And thanks to that, we have already initialized the state. So as you can see, we don't have here with state, because with state is somehow hidden in scope of the with entities, which will initialize our store with the state having the collection of the entities, IDs of these entities, and so on. And then thanks to this, we can patch our state by utilizing a lot of helper functions like set all entities, add entity, update entity, remove entity. There is even more at the documentation page, but the entire idea is to simplify the way we can manage our entities by utilizing the signal store. So by look at that, we can see how simple fetching the users and setting them to the state and propagate this data to entire components that utilize this store is extremely simple. And okay, so here we can see how this all Lego stack can work together. We might have with state, with entities, with computed, with methods, and with hooks. And as I mentioned at the very beginning, we are just putting one, I mentioned above, but actually below each other. And they all compute together at the final state of our store to just single item, which will be the to-do store containing all of these properties, all of these methods, which we can then utilize in scope of our components. What is also extremely powerful in the signal store, it's creating your custom reusable blocks, right? So we can create our custom store, signal store feature, which we can then reuse across of various stores. So as you can see here, I am using my with call state. With call state is pretty known pattern, initialized and introduced for me. I don't know whether in past someone else introduced it earlier, but probably for a lot of people from Angular, it was introduced by Alex Okrushko, one of the creator of NGRX store management. And that solution is here simply to standardizing the way we are managing the loading state of our entities and data in scope of the store. So simply by creating this kind of the reusable Lego blocks, I have standardized the way I will be managing the state, which informs me about the current process status of action, let's say, right? Of status of the action, whether we are currently in the loading state or whether the entity already or action has been loaded or whether there's some kind of the error occur. And thanks to that, I can reuse this kind of the block in multiple store and manage this kind of the information, right? So in our example, we have something like load products. So simply I am calling with call state, which is my custom store feature. And then in scope of load products method, I have simply already in store function, which is responsible for set loading, which will immediately set the state for loading. And then whenever I finish with this action, I can set loaded, which will immediately set my call state that the data has been actually loaded. And this kind of the flags, of course, we can utilize in scope of our components to manage the proper display of the information for the user, whether that will be some ghost elements or something else. So what are the common patterns, best practices? I already mentioned one of them, that we can keep our signals private and expose only computed to the outer world. So whoever consume our... I will answer, Adam, your question after all, okay? Because I don't want to focus on this one. So again, we can expose only what we want. We can keep our signals private for the external world, and this way we might be sure that no one will override it. We can use computed for derived state. We can use effects for side effects only, like logging, analytics DOM. We have to remember that we shouldn't perform any kind of the signal synchronizing or data fetching in scope of the effects. We can use linked signals for fields, but that might not be the case in the future. But so far, they can perform this kind of the functionality for sure. And convert signals to boundaries. So we can use toSignal for observable API. What we should avoid is like using effect to update other signals. So already mentioned, we should try to use the linked signal for this purpose, or compute it when we can. We shouldn't put any async operations in computed. I believe in effects for fetching data as well, but for the logging purpose, it's fine. We should avoid exposing writable signals from services. Rather, we should use the read-only or computed. Also worth mentioning that the signal store is by default read-only for the external world. We can like expose the possibility to writing to the signal to the component to the signal store from the components, but by default it's abandoned, and we cannot, it's restricted. And we should avoid mixing observables and signals randomly, and we should protect our services by utilizing as read-only. So we have like only 30 minutes to discuss about that. But as I mentioned during the discussion with the Chris, if you would like to go deeper, like take a look at the best practices in managing the signals, or take a look at the signal forums, how to manage your state with the signal store, perform some practical examples like creating the state management store for the e-commerce cart, because that kind of the example application we are working on during the workshops. I strongly encourage you to take a look at my workshops, which you can find on the House of Angular page. Also for this webinar, I have like prepared the dedicated discount for you for only 3 people, because we have like 3 spots left only, which is Angular 70, and it will create the 70% discount for you. So yeah, as I mentioned, if you would like to go deeper with managing the state with the signal, getting into the signal store, I strongly encourage you to take a look. And right now, I believe it's time for the Q&A.
Yes, it is. But first, thank you, Matt, for the very insightful presentation. That was really informative. And yeah, we can jump to the Q&A session. So guys, it's like a last minute chance to add your questions. We already have some, so let me bring them to the screen right now. The first one is from Damian. How hard it would be to migrate bcap to signals from RxJS? Some kind of migrator helper, perhaps?
Yeah, so as I mentioned, like, I don't know whether there is really a reason. Like, I know that the signals are the latest pattern and so on, but also it might not be worth the effort and time it will cost you to just really start migrating your old code. Maybe the best way will be like start with the signals since some point, and then since some point start creating the new services, new properties, and so on by utilizing the signals. And whenever you actually cannot like bring something completely from scratch because something is already or a little bit written in the RxJS, try to play around with this RxJS interrupt. Yeah, because otherwise it will be big effort, and I don't know whether there are really some shortcuts you can do to make this migration easy and smooth. Of course, by looking at the application and so on, we can like prepare and think of about some migration path which will be the most friendly for the developers and safe for the application, but there is no probably general rules we can apply like everywhere, and it will create the smooth migration process for everyone. That's my opinion, to be honest.
All right, so let's get to the next one, and this is the one, I believe, from Adam. Is there any pattern in Signal Store to create a generic store in a library included in your application and then expand it with some methods, effects, and etc.?
Yes, I believe there is a possibility. As far as I understand your question, Adam, so recently in my application, I created something like with template entities. And let's say I have like a lot of very similar interface entities which share exactly same like endpoint for every of them. And I created like some generic store, as you mentioned, like with template entities, something like that. I don't remember exactly that name right now. And under that one, there were functions to add, get, delete, and so on, these templates. But each of these templates, of course, had like its own model, which shared the interface between them. And like the endpoints were very similar with the different, let's say, slash at the end, like whether that was template for email, template for SMS, and so on. But under all, they have some common interface based on which I could create the generic store for them. But after the all, when I utilize this generic store as my custom store feature, to each of them particular store, I have been adding some custom and dedicated methods, effects whenever I need it, right? So my generic store has containing the most generic and common methods for all of them, like delete, add, update. But for example, some of them could be shared via the SMS or shared via the email. And all those dedicated methods actually were these methods which you call expanded, right? So had the generic store and expanded it with my custom methods. So definitely it's possible.
All right, thank you for the explanation, Matt. And let me bring another one, and this is for KT. Is it a good practice to trigger API calls from within the NGRX Signal Store with methods and update the core state based on the incoming response?
Yes, I believe like that's the purpose of with methods, and that's the best practice you can do, right? So the fact that the state is updated from the within the state, not from the external world, is actually something what create the clean code for us. And that like the fact that the state can be updated from the single place, which is state itself or store itself, it's the good practice. Otherwise, it's tough to track from where we actually updated the state in our store.
All right. And then we have plenty more, but let me bring at least some quick ones. Will Angular become zoneless in the close future?
It's not first time I see this question, and I am not always sure when I'm answering, but I believe it's already zoneless. So we can be zoneless right now, probably.
Yeah, and if I'm not mistaken, from 21 it will be the default.
Yeah, but
Yeah, I guess, as far as I remember. All right. What else do we have here? Quick question. Are the signals more common way now to use instead of observables, like performance-wise? Since some core Angular by default gives you an observable, so it's some performance overhead.
So, like answering the question, I believe like the signals are more common way now instead of the observables. So if I will be starting something from scratch, my destination goal will be like to go with the signals whenever I really can go with the signals. But there is also like places where we probably cannot go without the observables, as I mentioned during the presentation. Even some, I don't know, listening for the input changes with the bounce time and so on is probably more elegant when we utilize RxJS in good manner instead of creating some custom signal-based functions with set timeout and so on, for me actually, right? So there are still places where I will go with RxJS and the request and all kind of this stuff. And regarding the performance, I strongly encourage you to take a look at the one of the most recent article from our colleague on Angular Love, from Arthur, when he really take a look much deeper into the signals and pointed out actually some edge cases where they might not be extremely efficient as we expect them, right? So I believe like we are still evolving with the signals. We are still learning a lot about the signals, and maybe by default, they can see like the best performance choose, but at some scenarios we can cause them being not performant well. But I'm not able to explain it only during this presentation, right? So I strongly encourage you to take a look at the Angular Love, and here is a dedicated article.
All right. So there is still a couple more questions in the chat, but we can't really get through them all because the time does not allow us. If, Matt, you have a chance maybe to jump into the chat to answer at least some, that would be great. And anyway, thank you for being with us today. And I hope to see you on the next meetup, actually.
Yes, I will be there. So we'll see pretty soon with our community.
All right. Take care. Bye.
Oh, thank you. Have a nice day. Bye.